So hello everyone, today we're going to discuss about coupling. So here we have our given, we have our topic which is coupling. So here a cast iron flange coupling is used to join two steel shafts 3 inches in diameter. So the diameter of the shaft is 3 inches and delivering a maximum torque of 10 kilojoules. So the two halves of the couplings are joined together by 6 bolts. We have 6 bolts. And then place equidistant on the bolt circle is 5 inches. So we have a bolt circle of, diameter bolt circle of 5 inches. And if the design stress, say, is 15,000 psi in shear, so we have shear of 15,000 psi. The bolt material, evaluate the diameter of the bolt. So what we need to find is the diameter of the bolt. So here, the equation that we're going to use is shearing stress is equals to, first, we need to visualize it. Visualize. So here we have, let's say, a, how do I draw this? A flange, okay? With, you know, with bolts here. Let's assume that this is, say, 6 bolts. So here, in this, we have 6 bolts. And then the bolt circle, which is here, is 5 inches. Okay. And then the shearing stress. So we have the individual bolts here. The shearing stress that these individual bolts are experiencing is here. So the area that we're going to need, since it's shearing, is the area here in the circle itself. This area right here. Okay. So the formula that we're going to use is shearing stress is equals to force over area. We know that force is equals to 2 times torque, then diameter of the bolt circle. So it's the bolt circle, this is the bolt circle, okay? And the area. So since this is a shearing stress, the area is parallel to the stress or the force itself. So this is not the stress, this is the force. So it is parallel to the force. So we have what we area of a cylinder, which is pi over 4. The area of a circle, which is pi over 4, d squared. So here, the diameter that we're going to find is here in the bolt itself. So it's the diameter of the bolt. You have the dB, okay? And since we are going to, let's say, find the individual diameter, we need to add in the equation the number of bolts so that it would, let's say, be distributed uniformly, okay? So first, we have the formula. So the shear stress is the shear stress for the bolt material. We have it, so check. And the torque is 10 kilojoules. So then here we have the conversions. The conversion is, we know that 10 kilojoules is just 10 kilonewton per meter, because 1 joule is equals to newton per meter. Okay, so that's not a typo, that's just 10 kilonewton meter. So we have the torque now, and the diameter of ball circle, and the area of the ball, what we're trying to find, and the end. So let's just input the formula. So we have 15,000 psi is equals to 2. We have the torque, which is 10,000 newton per, say, meter, or 10 million newton per mm. Okay, since this is, let's say, newton per mm, we need to convert it to the English unit. So conversion for newton, say 1 pound force, 1 pound force equals to 4.448 newton. And say, let's just convert this first. Okay, since this is kilonewton, we know that um, 10 million newton mm. So you know that 1 pound force is equal to 4.448 newton. Okay, and then 1 mm, I mean 25.4, let's say 1 inch, I mean, is equals to 25.4 mm. Okay, so here we have our conversion. So 10 million. 1, 2, 3, 1, 2, 3. 1 over 4.448 times 1 over 25.4. We have 88,511.87 pound force per pound force inch. Okay, so now we're going to our solution. So the continuation is, we have 15,000 pound force per inches squared, just the psi, and to the torque, we have 88,511.87 pound force inch, and then divided by, we have the ball circle of 5 inches, and then pi over 4, and we have what we're trying to find. We have the bolt diameter squared, and also the number of bolts, which is 6. Okay, we have bolt diameter, so 2 times 88,557, 5 times pi over 4, 15,000, right? 15,000 and 6. We have 0.501 square root. Then we have a diameter of bolt of 0.71 inches. That's it. So I hope you have learned something here. And so see you again next time. Bye bye.